we have the radius of this circle has been given to us as 3, and this angle here subtended from these two tangent lines is 60 degrees. So with that, what is the area of this shaded region? First of all, what you're going to do, let us let these points of tangency, let this be A and let this be B. Let this point be C and let this center be O. The next step is we're going to connect the center O to the points of tangency B, point B, and O to point A. Just like this, okay? So we've connected O to B and O to A. As you can notice, OB and OA are both radius or radii of this circle here. And the radius was already given to us. So OB is 3 and also OA is 3. Now we know that from tangent to circle theorem, the angle between the radius and the tangent is always 90 degrees. So this angle between the radius and tangent is 90. So this is 90 degrees. Also, this is 90 degrees. Then also from the two tangent theorem, which states that if two tangent segments are drawn to a circle from the same external point, just like this one, these two tangent lines, BC and AC, are drawn from the same external point C, then it implies that those two segments are congruent. That implies that AC is congruent to BC. Now, let's first focus on the quadrilateral OACB. We know that the total interior angle sum is 360 degrees. Since this angle here, OBC, this is 90 degrees, and this is 60 degrees, this is 90 degrees, and we know that sum of the interior angles of the quadrilateral is 360 degrees. That implies that this one here will be, so angle BOA will be equals to 360 degrees minus 90 degrees plus 60 degrees plus 90 degrees, which is equals to 360 degrees minus 240 degrees, which gives us 120 degrees. So this angle is 120 degrees. So that implies now that to find the shaded area, so our shaded area will be equals to quadrilateral area of OA to be area of OACB minus the area of this sector here, minus area of the sector OBA, okay? So this implies that now we have to find the area of the quadrilateral OACB and the area of the sector OBA to be able to find the area of the shaded region. So the next step we're going to do is we're going to connect point O to point C, just like this. So we've drawn this line. So as a result, you can notice that triangle OBC is congruent to triangle OAC, this one here. This upper triangle is congruent to this down triangle. That implies that this angle here is equals to this angle here. So if the whole of this angle is 120 degrees, that implies that this one will be 120 by 2, which is 60 degrees. Also, this one will be 60 degrees. Okay? Also, this angle here, BCO, is equals to angle OCA. So this one is equals to this one. So if the whole of it is 60, this will be 60 by 2, which is 30 degrees. Also, this will be 30 degrees. Now, focusing on triangle OAC, it's like this. So this is SC, this is O. This is 90 degrees, this is 60 degrees, this is 30 degrees. As you can notice, this triangle here is a special 30 to 60 to 90 triangle. Okay, it's a special triangle. Now, since this is 30 degrees and it's our smallest angle, so its opposite side will be the smallest side. So this will be smallest side, and the angle which has the largest side, which in this case is 90 degrees, its opposite side will be the longest side, okay, which is OC. So OA is the smallest side and OC is the longest side. And in such a triangle, which is a 30 to 60 to 90 triangle, the longest side is twice the size of the smallest side. So if the smallest side is say 1, okay, that means the longest side will be 2. So the longest side is just double of the smallest side. So if this is 1, this will be 2. So if this is 1 and this is 2, we can find this side, what it's equals to. So for SC, it will, using Pythagoras theorem, since it's a right triangle, a squared plus b squared is equals to c squared. And our a is AC, so AC squared plus our b is 1, so 1 squared is equals to our c, which is 2 squared. Therefore, AC squared is equals to 2 squared, which is 4, minus 1 squared, which is 1. Therefore, AC squared is equals to 4 minus 1 is 3. Find the square root on both sides. This cancels. Therefore, AC is equals to root 3. Therefore, this side AC is, if this is 1, this is 2, this is root 3. But if we are to go back to our original diagram, we can see that OA is 3. And in this case, we are saying OA is 1. So to make it 3, we are going to multiply all sides by 3. Okay? Multiply each side by 3 to balance everything. So this side will be equals to 3 times 1, which is 3. This side will be 3 root 3, and this side will be 6. So therefore, our SC is 3 root 3, and our OC is 6. Okay? But remember, SC is congruent to BC. Therefore, if this is 3 root 3, also this side is 3 root 3. So now let's find the area of triangle OAC. Okay, area is equals to a half times base times height. So it will be a half. The base is 3 root 3, and the height is OA, which is 3. So this will be equals to 3 times 3 is 9, so 9 root 3 over 2. So this is the area of OAC. But remember, area, triangle OAC is congruent to triangle OCB. Okay? Therefore, area of quadrilateral OACB will be equals to 9 root 3 over 2 plus 9 root 3 over 2. So this will be equals to, so here, using crisscross, 2 times this is 18, so 18 root 3 plus 2 times this is 18 root 3 over 2 times 2 is 4. This gives us, we factor out 18 root 3 into 1 plus 1 over 4. So this is 18 root 3 into 2 over 4. This 2 goes into 4 2 times, and this 2 goes into 18 to give 9. So this will be equals to 9 root 3. So the area, therefore, area of quadrilateral OACB is equals to 9 root 3 square units. Now for the area of sector OBA, this one here, area of a sector is theta over 360 degrees times pi r squared. This is how we find area of a sector. So this is equals to, our angle here is 120 degrees. So it will be 120 over 360 times pi into the radius of the circle is 3. So into 3 squared. So 120 goes into 360 3 times. So we have 1 out of 3 times pi. 3 squared is 9. So times 9. This is equals to 9 pi over 3. 3 goes into 9 3 times. So area of the sector is equals to 3 pi. And remember, we said to get area of shaded region, this area is equals to area of quadrilateral OACB minus area of sector OBA. Okay, so this is equals to, this area is, we found area of this to be 9 root 3, and we found area of sector OBA to be 3 pi. So area will be approximately 6.16 square units. So this is the area of the shaded region, this one here. Thank you so much for watching. Kindly subscribe to this channel if you haven't done so yet. Like this video if you enjoyed it. Comment your thoughts about the video. If you have things you'd like to add, you can share them in the comment section. And do not forget to share this video with your friends and family for an enlightening experience. See you in the next video.